Before we get started with the deep dive, let's have a look at the overview of the workflow that's provided by the Visual Machine Awareness product suite. This ecosystem, which you can see here, is based around enhancing processes taking place on the shop floor, which today require operators or quality analysts to use their eyes. It consists of a workpiece, tool, or object to be monitored in step 1. In step 2, we use an IP camera, which is connected to SINUMERIK Edge. Step 3 involves the model training and creation process using a cloud-based infrastructure. Following this, the model can then be deployed back to the edge device. And finally, we offer integration with industrial controllers for automation so that we can use the model we've trained to realize multiple use cases. This workflow can be applied within multiple environments, such as within a machine cell, or on a shop floor. This workflow enables multiple products within this suite. You can see here in cloud, we have Manage My AI, managing the cloud-based model creation and management of the models themselves. And we also have Protect My Machine Setup, which focuses on workpiece identification and monitoring, and Analyze My Workpiece Tool Check, which is focused on operations monitoring and quality analysis, specifically with regards to toolware analysis. In more detail, you can see an overview here of the different use cases that are covered by each application. For example, Protect My Machine Setup enables workpiece process monitoring and identification, but also for an object detection and environment confirmation, as well as quality analysis and completeness checks. Analyze My Workpiece Tool Check is focused on tool and toolware monitoring, and Manage My AI enables cloud-based AI model creation and deployment back to the edge devices. As promised, today we'll be taking a look at Protect My Machine Setup and Manage My AI. Before we get started with the usage of the applications, it's important that we run through a few easy prerequisites in terms of the configuration for the apps to make sure that we have everything set up correctly and that we're ready to use the apps in the correct way. The first step is to navigate to your MindSphere tenant. Here's where we have all of our cloud-based management for SINUMERIK Edge applications and also for our Visual Machine Awareness apps as well. You can see here that the first step is to select the Edge applications and make sure that they're installed on our Edge device correctly. To do this, we can navigate to Manage My SINUMERIK Edge App Management. We click on the app icon, and we're taken to our app management page. Here, we can simply type in the machine the machine that we want to make changes to. We can select our device directly, and we'll see which Edge applications we've already installed, if any, and if we need to install the relevant applications, we can go here to New Application. You can always find the details in the documentation about which apps are required, but for example, using Visual Machine Awareness apps, you need to install Protect My Machine Setup and Analyze My Workpiece Tool Check. Always check to make sure that you're using the latest available version in your tenant. By clicking this button, New Application, we can easily navigate to see the relevant application names and versions which are available for us to download. For example, also Analyze My Workpiece Tool Check can be seen here. As we've already installed the applications on this device, a few things of note. Very important here is that we can see we need to have our application instances running when we use the devices. We can also remove the app instances or configure their setup as well. But most importantly here is we want to make sure that we are reviewing the additional documents. Please be sure to download and keep these documents in a handy spot so that you can reference them throughout the configuration process. They are particularly helpful, especially the first time going through the process. So now that we have our applications installed, we also need to make sure that we have our cloud-based application, Manage My AI, available in our tenant. To do this, once you've purchased the application, it's been provisioned to your tenant, you should see this icon, Manage My AI, appear within your tenant, as long as you have the user rights set up within the MindSphere application you will be able to see this icon directly. So just make sure it's available before you start the process. Now that we've confirmed that all of our applications are available and good to go, we'll navigate back to our relevant edge device for today, and we'll have a look at the sensor adapter. So configuring the sensor adapter is the first step in setting up a camera to work directly with our SINUMERIK Edge device. There's two things to monitor in this process. The first is, from the additional documentation, we have two very helpful manuals for both of the Edge apps. We have a camera configuration manual for Protect My Machine setup, and also for Analyze My Workpiece tool check. These manuals are very similar, and you can reference them individually depending on which application you're installing. But this workflow gives you an overview firstly of how to install the sensor adapter application as we've just reviewed. And if you scroll further down to the next section, you can also see here which configuration steps you need to take. So here you can see all the configuration editing steps. Particularly important here is that you can configure one camera directly by making direct changes to the configuration log, or you can configure your application to support two cameras. You can see all the notes and also sample configurations directly here in the documentation. And if we look back to our MindSphere instance, we can click on this configuration directly, and we'll see that it loads all the details as we saw in the documentation. So we can make any changes that we need to here, following the documentation directly, and we can enable one or two cameras. Now that the sensor adapter is set up, I wanted to shortly give you an overview of how to reference our documentation and best practices to configure the IP camera directly. The best tips we have for these options are found in the operating manual. We have separate operating manuals for Protect My Machine setup and also for Analyze My Workpiece tool check that come with really helpful tips about how to set up the camera, configure it correctly, and make sure that you're ready to gather data once you've installed the apps on the shop floor. For example, you can look here to camera installation, and you can find a helpful list of all the specifications, what we recommend for the camera directly, and also cameras which we have used in our testing. You can also find details about what different protective housings offer you, depending on if you install the camera within a machine tool or near it. And you can also, for example here, see details about how to install the camera if you're using Protect My Machine setup for one workpiece, where the camera can be positioned, how to connect it to the Edge device, and what a sample configuration looks like. We also provide options concerning more workpiece examples. In this case, you can find very similar and helpful details for Analyze My Workpiece tool check as well. If you navigate to camera installation, again, you can see here our specification and recommendations for this particular use case. It comes with a unique guideline, which is different and specific to the Analyze My Workpiece tool check workflow. So here you can see a wide range of recommendations concerning how to position the camera, what kinds of defects to look for, how to build your use cases effectively, and also how to reduce issues coming from reflections or lighting problems that may occur using a microscopic camera. We also have recommendations for enclosures and housings in this use case as well. And you can always reference this information to ensure that your camera is set up correctly and ready to go for the use cases, which you can cover in both of the applications. Once the camera is set up and you're satisfied with the implementation that you have, there's one more important step which needs to be monitored, and that is the configuration of an MGUD variable within SINUMERIK so that you can remotely and directly access the application itself through G-code. To do this, we offer the installation manual, which, among other steps, offers multiple configuration approaches that you can reference here. For example, if we go to Section 5, Configuration, this step will tell us how to configure the SINUMERIK adapter directly. Important here is to note that you need to install an additional application if you want to call the application on the Edge device from your SINUMERIK device directly. So it's called SINUMERIK adapter, and you can follow these simple steps listed here to install the application and then also to set up your MGUD variables, which are relevant for controlling the application directly from the SINUMERIK controller. For example, Protect My Machine Setup uses these two examples that you can set up in this procedure. And of course, Analyze My Workpiece Toolcheck also offers an overview of these two options. You can see here again the instructions for installing the SINUMERIK adapter in MindSphere, and also the route to create these two variables on the SINUMERIK side, now specific to Analyze My Workpiece Toolcheck. The last tip, and also included in the documentation with your Edge device, is before you set up the device for the first time, be sure to check the latest README that we've published with the last version, as this can provide you with new tips and hints, and also can support you with any restrictions that may be available in upcoming versions of the app. You can see we provide individual READMEs for both of the applications, and of course you can always contact your Siemens hotline representative if you have any questions about how to proceed. So, now that we've completed our prerequisite steps, it's time to dive into the application. Here we can see the web-based UI where we have direct access to the application running on the Edge device at the machine. This is the home page with a variety of different tabs and options that we can view. You can also navigate via the sidebar on the left-hand side of the page. Before we look at the details, there are some basics which you can set up ahead of time. In the top right-hand corner, you can adjust the language settings. As an administrative user, you can also access the settings page. Here you can decide which types of data you would like to be stored in the application. Looking at the different tabs that are available, we can use online analytics in order to view a live stream directly into the machine, and also to activate and trigger different models manually through the UI. We can use the Create New Models page in order to generate a data acquisition process and also a labeling process in packaging and sending images to MindSphere for model training with Manage My AI. We can use the Manage Models page to upload new models and manage existing models and datasets that we've already created within the application. The reporting page enables us to view all triggered results in a historical view, and the dashboarding page gives us a visualization of all the results that we've had so far. To get started, we'll look at an example of how to create new models using Protect My Machine Setup. First, you click on Create New Model. Here you will see, as a part of Protect My Machine Setup, there are several standard use cases which are offered. Here we can see workpiece identification and also workpiece rotation analysis. Workpiece identification should be chosen when selecting different criteria to differentiate between different types of workpieces. This could have to do with different workpieces that are being machined throughout a process or within one program, or to distinguish between different programs entirely. Workpiece rotation analysis can also be used within an existing program to confirm that the workpiece has been placed correctly within the clamping scenario and also within the machine directly. To start, we will first select workpiece identification. After we've selected our use case, we will now be directed to select the camera which we want to associate with our data acquisition process. In this case, we can see a live stream directly into the machine tool, which enables us to see exactly what the camera sees and ensure that we have a good positioning of the camera field of view and of the workpieces themselves. On the left-hand side, you can select the camera. In this case, we have only one camera installed, but if you have more than one camera, you can switch between the camera fields of view here. Important is that the workpiece is placed centrally and of clear view within the camera's view itself. In this case, you can see that while we're viewing the live stream, we can tell that the workpiece in the background is well centered, the lighting is good, and we don't have any issues with reflection. When we're ready to continue, we can press Accept to configure the camera view alongside our model. After we've selected our camera view, we are now redirected to the next step of the model creation process. At this stage, we can create a name for our model, and we can also add multiple classes in order to enable the data acquisition process. At the top of the page, when you open it, you will be able to define the model name according to your wish. Here you can edit the name and set it in place. After this, you can add classes. Classes are a series of functions which you can add multiple images to. Classes should refer, in this case for workpiece identification, to different workpieces directly or different phases of a processed workpiece throughout one program. To add classes, you can simply click the button on the left and add classes here within the table directly. In this example, it's important to ensure that your camera view remains stable after you've connected the camera and selected it for your use case. Here we can see we have the workpiece in view, and specifically, we're going to be working with the variant workpiece 3 in this example. Before we collect our snapshots, there's a few important things to keep in mind. First, on the bottom right-hand corner, you can see that you can enter a new number of images that will be taken. When we're using this manual data acquisition approach within the user interface, we just need to press the snapshot button in order to collect images. In this case, we will collect one image as the image input is defined as 1, but you can update this number up to 100 images at one time. Important to note is that per class, it's recommended to collect at least 200 images in order to get a full model training result. Also important here, as we're collecting data, is to try and introduce some variety throughout the process. In this manual approach for workpiece identification, you may switch the workpieces directly when defining between classes, but it's also important to follow the training data collection notes at the bottom of the UI. Here we have recommendations about avoiding reflections or light hindrances within the view, and we can also try and change the lighting slightly so that the model will become more robust over time. Instead of having to define specific features on the workpiece itself, we can just collect data in different environments, and our model training pipeline will enable the full training in the background once we get to manage my AI. To collect snapshots, you click this button within the class table, and snapshots will be collected. Once the snapshot collection process is completed, you will receive this success message. It confirms that the training data has been gathered for this class, and also the name that you used for the class directly. Once you're ready to continue with collecting more data, you simply can press Accept and Close and move back to the data acquisition page. After we've accepted and closed the confirmation, we are directed back to the data acquisition page. Now we can see that we have one new image which we collected for this workpiece class, based on the number of images that we defined on the bottom right-hand corner of the screen. Following this, we can continue to add new data for the different classes. We can update our model by collecting more snapshots and periodically changing the lighting conditions and the overall environment that the workpiece is in throughout the process. In this case, it's important to ensure that external parts or distractions are kept out of the view as much as possible. In another use case, such as workpiece rotation analysis, we would also want to add new classes for different rotations of the workpiece. Again, looking at different options in terms of lighting and changing the environment so that our model can become more robust and more adept at handling different scenarios within the machine tool. As a user, you have full control over adding different classes and changing the labels here within the Create New Model process. When you're ready to submit images to Manage My AI, you can use the buttons here at the bottom to control your next step. If you're not ready to submit data, you can go directly to the model management page and come back and edit the steps later. You can also do this at any time throughout the process. If you're ready to submit to MindSphere and the Manage My AI application, you can click on Submit. Once we've confirmed our data set and hit Submit, we are directed to a summary page. Here we can again view and confirm the name of our model, and we'll also be presented with the labels and classes that we have created, as well as any new images, and additionally images that have already been submitted as a part of this model training process. Before we submit the data to MindSphere, we also have the option to download the data directly onto our local device. This can be helpful for storing the data offline, or for keeping record of which images have been taken through this model data acquisition process. When we're ready to submit to Manage My AI in MindSphere, we click Confirm and Submit. Here we can confirm once again, and once we Confirm this process, the data will be uploaded to MindSphere. It can no longer be downloaded on the Edge device, but will be available in Fleet Manager, as we'll see in the Manage My AI section of this video. As we confirm, the data will be packaged together and we will receive this summary page. This confirmation tells us that the model data has been submitted to MindSphere and that the upload is in process. Now that we've successfully uploaded our data into the MindSphere application Manage My AI, we're going to look back at the MindSphere tenant and use two applications to manage the data, get an overview of our models, initiate model training, and also to access a finished model all out of this cloud infrastructure. The two applications we'll be using are the Fleet Manager, which is available as a standard app from MindSphere, and also Manage My AI, which relates to the Edge applications we've reviewed so far. So in the first step, we're going to open up Fleet Manager to get an overview of the data. You can see here that within the MindSphere Fleet Manager, we can search for our industrial Edge device here, so SINUMERIK Edge asset that we've been using before. And with this device, we can also filter for a number of different files in place here. You'll see within the Fleet Manager protocol a mixture of log files, image files that you've uploaded directly from your Edge device, and also .model files, which are the completed AI models generated by the application Manage My AI. In this case, for example, if we filter for image-based files or .png, we can see an example of all the recently uploaded images that are available for our viewing again in MindSphere. This is important because you can always access the data that you've uploaded to MindSphere from your Edge devices through one singular platform. You can simply select as many of the options as you'd like and download them directly to your device. For example, once you have the images, you can then view them locally, as you can see here with this example. Another aspect of the Fleet Manager which you can look at through the filtering is the models themselves directly. So here you will also find completed models once they're available. But in order to get to these, we first need to go back to the Manage My AI application to understand how we generate these models. So from here we go back to the Launchpad and we click on the application Manage My AI. This brings us here to our main management table of the application. This is a simple interface that enables you to manage the data you've uploaded here to MindSphere and to the application Manage My AI, and to approve these different training requests from the Edge devices for AI model training, which will be completed by our team and algorithms that run in succession with Manage My AI. You can see here in the table a range of different Edge devices which have submitted model requests, such as the Edge devices we've been working with so far. And you can also see examples of which application is sending the data. For example, Analyze My Workpiece toolcheck over its application name here, or Protect My Machine setup. Here you can also manage and see the model name which is available, so you can check and see which of the models you have uploaded directly. And also, as a helpful hint, we include the timestamp. So at what point was the data received, and has it been submitted to MindSphere directly. In the status, you will see a number of different options that you can view. So for example, if a model is still pending approval, it needs to be approved for model training, into which state it will then go to in progress or will be underway for training. You may also see that there are failed results within your Manage My AI table. Generally, this message is caused by having an insufficient number of training data available to start the training. Keep in mind that you generally need a minimum of 200 images in order to initiate a training, and it may be that the status is failed because it's not yet been able to start due to an insufficient lack of data. It can also be that there has been some kind of technical issue or a connection problem concerning the ongoing status, and you can always check with your hotline representative if you do receive this message. In general though, when the process runs as planned, you should see your request here as pending approval, at which point we can come through and approve the model. From here you will receive a confirmation, and here as a user you can accept the additional fees that will come with the training hours associated with this model. You can get more information about the training fees and how many hours are generally used for a training by reviewing the documentation with your sales representative, and also through the product sheet and specific terms which are directly linked here in the application. Once you're in agreement, all you need to do is check the box and approve the model training. At this stage, you'll receive a confirmation that your training has been purchased successfully and that your training is now in progress. Once the training is completed, you will see an update of the status here in Manage My AI, telling you that your model is now available. And this takes us back to the Fleet Manager aspect. Once your models are available for download, they will then be published as .model files here in the Fleet Manager page of MindSphere. So you simply navigate back to Fleet Manager. Once you've seen that your models are available, you can download the files you need to work with and save them directly on your local device for uploading them to the Edge application in the next step. You can continue to use this process to manage your AI models, maintain the status, approve new trainings, and have an overall picture of which Edge applications have sent which data to Manage My AI. On the Manage Models page, we see a list of all the models that we have created for this particular Edge device. We can see the name of the model, when it was last updated or edited, which camera is associated with this model, and also what the status of the model is. If data has already been submitted to MindSphere, we will see this status here at the bottom. If the model is ready and available for use here directly in the application, we will see the status available. By scrolling over the status of the model itself, we can see exactly which model file has been uploaded and used here in the application. In this case, we also have the ability to activate and deactivate models. By simply switching this toggle switch, we can use different models throughout our application. A model needs to be activated before it can be run on the online analytics page or before we trigger it out of CNC or G-code in order to activate and trigger the model. In this case, we can also edit existing models by pressing the Edit button on the right-hand corner. This will take us back to the Create New Models page, where we can add additional data points to our model and continually improve and update the training dataset for the model itself. On the right-hand side, we can also delete or remove models that are no longer relevant or are outdated. To upload a new model file, which has been downloaded from MindSphere, we simply use this upload feature here. By clicking this button, we can upload a file from our download section or from any other location on our local device in order to update the model and the edited status here directly on the Edge application. The file will automatically be mapped to the correct model, and the status will show as available once the model has been uploaded. Following this step, we can navigate back to Online Analytics in order to see the status of our live stream and also to use the models directly. At this time, we can see that the machine is being loaded. While we're manually using the Online Analytics page, we can see a live stream of the camera view directly into the machine. At this time, it's relevant for us to perform the workpiece identification model. In order to do this, we can wait until the operator is finished and make sure that our workpiece identification model is activated. When the environment is clear, we can press the I button to run the model. Now we've received a manual result over the UI, showing us that Workpiece 3 has been detected as a result of our model training. This information can also be provided back to SINUMERIK, and an automated process in which you can run the model activation and triggering out of G-code will be shown later on in this video, so stay tuned. When you're ready to review the overall results of your models, you can use the reporting and the dashboarding pages, which you can access from the home page. When using the reporting page, there are several important factors to keep in mind. First, at the top of the page, you can see that you can filter and sort all of the results according to the model type that you've chosen, the result of a specific model, the trigger type if it was used within the user interface or if it came from the control or SINUMERIK, and you can also filter according to a start and end date. Important here is that as you filter through the table results of the reporting page, you can see also a snapshot of what the camera live stream saw at the time that it triggered a certain result. You can filter through the snapshots by simply clicking on the different results directly in the table, and the new snapshots will be shown with different variants of the workpiece throughout time. You can also download and export certain results from this page, which will enable you to receive a table and also the images as separate files. To visualize the results, you can navigate to the dashboarding page. In this example, you can get an overview for this specific edge device of the different types of results that have been run across a number of customizable dashboards throughout the page. Again, you can filter according to model, result, the trigger type, and the start and end date on this page. And you can also see here a wide range of visualization options which can be changed according to the user preference. You can sort according to the number of work items that have taken place, the different types of results that are received, and you can view them in different forms. This can be used directly on the shop floor or accessed remotely by quality analysts in order to get an overall picture of how the application is performing and what kinds of results are being received at this particular machine. To return to the home page, simply use the left-hand sidebar or the back button. Here you can see a summary of how you can automate the model triggering and model result process directly through updates to your G-code on SINUMERIK. As you can see here, an MGUD or MGUD variable can simply be inserted into your NC program to trigger the activation of a model and also to trigger the results of that model directly within your control environment. This means that anytime you want to trigger the usage of an AI model from Protect My Machine Setup or Analyze My Workpiece toolcheck, all you need to do is insert the pre-configured MGUD that we reviewed in the Prerequisites video directly into the desired position of your program. For example, if you would like Protect My Machine Setup to initiate a workpiece check on rotation or identity before a program takes place, you can put it at the beginning of your program, or if you have intermediate checks, you can also enter the trigger directly throughout the program elsewhere. This same logic applies for Analyze My Workpiece toolcheck using the second variable available here. You can also directly display the results that are triggered by your model in the Edge applications by using the Results by MGUD option. Here you will see directly within the alarms panel of your device which result has been triggered by your AI model. This result can then be used to trigger further automation processes such as stopping a process or continuing with a process according to the result that you receive. These steps are very important because they can help to reduce any manual labor involved in the configuration of the process and can integrate artificial intelligence models directly into your production processes. There are also further use cases available for this kind of integration. For example, you can see here an expected string which can be used to automate the data acquisition process by entering a model name ahead of time and also an expected result that's in place. A user can also automate the data acquisition process, which is available manually within the user interface as well. Please consult the user manual further for different details and information on these topics, or contact your Siemens representative if you have any questions. Once you've enabled the trigger and result MGUDs directly within your application and within your G-code, you can then see the results as being triggered by CNC or SINUMERIK directly within the Edge applications themselves. Here you can see an example from Protect My Machine Setup. This logic also applies for Analyze My Workpiece toolcheck.